Perfect, thank you. So Barris and I will be speaking today about scaling expert elicitation with an R-powered platform. So often in health economics, there's a critical decision that must be made, and that requires quantitative input. So often a model is built, usually computational, and this is developed to simulate the scenario that requires the critical decision. And there's often a data gap, so essential parameters may lack empirical data or published literature. For example, long-term survival extrapolation is a particular gap because this is unknown in the data. And the solution is to sort expert opinion to fill these information voids. So you can see here that expert opinion is often the last case after all of the above data inputs. So the problem is, how do we convert the heterogeneous opinions of experts into a single probability distribution to input into a model? And the solution is structured expert elicitation. So this aims to provide transparent and rigorous process to convert expert opinion into data. So it does this by quantifying uncertainty. So rather than giving a single number, experts can provide a range of possibilities in the form of a probability distribution. This aims to minimize bias by introducing specific protocols to reduce the risk of experts being overconfident or influenced by groupthink, and creates an audit trail. So this makes the decision-making process more transparent, repeatable, and scientifically defensible, rather than using the more ad hoc expert elicitation approaches of just asking experts for their opinion without the rigorous process of structured expert elicitation. So we have found there are significant barriers to structured expert elicitation being adopted, particularly in HTA. So the statistical analysis can be complex and requires the addition of a statistician into the project team, which can obviously be expensive. And there's a lack of transparency, particularly in the questions that have been asked to the experts, how these were asked, and the whole process not being auditable. There's administrative friction, so you need to email all of the experts and perhaps try and get them all available at a specific time, collect all of the data from all of the experts and store that somewhere and track their progress. And this is also linked to the decentralized workflow. So trying to keep an eye on all of the experts, what stage they're at, all of the admin required can make that particularly time consuming. And then subject matter expert engagement. So trying to get a group of experts from across the country, all available at the same time, all engaged with the same materials, and all available, particularly on a live workshop, can be particularly difficult and can be a large barrier to conducting structured expert elicitation. So conducting structured expert elicitation with the platform is a way to mitigate some of these barriers. So the platform supports both asynchronous and synchronous methods, which allows experts to input their estimates independently in their own time or via a Delphi-style method, or it can be used as a live workshop tool as well, if you do need to have all of the experts available to discuss the results together. So within the platform, some of the steps are automated, which significantly increases the speed of the elicitations. For example, pooling the distributions. So the platform uses Shelf to automatically pool the distributions across experts. So there's no need to hire that statistician into the project team. As soon as the expert elicitations come in, they're automatically aggregated and shown directly on the platform. This also allows a final report can be downloaded, and this is automated, so you can download that directly from the platform, showing exactly what the experts provided as their answers to each of the questions. And the automated outputs also include all expert responses, the JSON survey object, the survey protocol, and conflict of interest statements. So the key here is the transparency, so ensuring every decision is documented and the whole process is auditable, making it much more likely to be accepted by HTA. So the platform is hosted on AWS, but uses an R server to conduct the statistical analysis and mathematical aggregation, and also the graphical visualizations. You can see here that experts input the data into the platform, and the administrator inputs all of the question information and background evidence. The platform uses the R server to perform the analysis, and then the database includes the data storage and automated reports with the output of the JSON object as well. So the steps to performing structured expert elicitation using the platform are first to create the survey, next to add the questions. So we have a series of question types that can be added depending on the outcomes sought. Next, it would be publish and send to the experts. And then you can view the responses directly in the platform and make changes to weighting, to the model fits, and different things like that, which can then be downloaded directly from the platform. And then the report can be generated using all of the information from all of the questions into a PDF that can be used directly in submission. So I'm going to pass to Baris to discuss how the AI piloting module can work with the platform.
Thank you, Lucy, and apologies for not showing my face. My camera is not cooperating this morning. So when we were discussing this project with Lucy and Dark Peak Analytics, we thought about how AI may add value to the whole process. Obviously, Lucy's description of the problem statement is quite obvious. What we wanted to check is, can we do anything prior to deploying this survey to experts? Because most of the time, we do have 1 or 2 shots with experts, their time, their engagement. And these surveys can be quite tricky to put together, from the way that we are framing the question to the data that we're providing, and how what type of answers we're expecting to see at the end. So we thought AI could be a good tool to test this out before it actually gets to the experts' hands. So there are multiple different things in here, but there are potentially more areas that we can expand to as well. One of them is piloting questions, making sure the questions are clear, understandable by the experts. Interpretability, validation, the way that we're using these technical terms are appropriate and understood by the experts, again, depending on their background. We can look at the sequence of questions, how we're framing them. And at the end, as a byproduct, we also get a synthetic expert simulation at the end, not only testing those different elements, but also creating a initial response to those questions that we created, which then can be put in the same platform that Lucy was mentioning, and then generate the report from that. Very quickly, I would like to demo this so that this is more tangible in your minds. I hope you can see my screen. But this is a very simple flow. Again, a lot more complexity can be added, but for the purposes of today's presentation, I will add a survey into this synthetic expert response generator, which is powered by AI in the background. First, it gets all the questions from the survey, along with the context and the background that we will ideally share with the experts for them to answer these questions as well. Here we have 5 questions. 3 of them are roulette. 1 of them is free text, and 1 of them is computing probabilities, basically filling out 100% of what may happen. Then the system generates experts based on that context and domain that we're working in. These can be user edited. We can change the composition of the panel. We can add statisticians, patient advocacy, other clinical experts, and so forth. But this is initial take on the expert panel generated by the system, looking at the context. And then using these personas or profiles, then we kick the process off And each of these experts are answering these 5 questions that we have in the survey. This will take a minute as experts go through the background material, what data they have access to, the context in which they will answer these questions, and then the system will get back to us with a summary of how experts dealt with each question, what type of issues they may have flagged, how they respond to these questions, so that we have an initial take on how the survey may actually read out. Again, this is in the background, making the calls to large language models with these profiles that we have at the top of the screen. By the way, this obviously panel can be designed in many different ways. We can add more experts in here, reduce it, bring in different profiles and so forth. This is all user editable. And while we're waiting for this, the example we have here is renal cell carcinoma. We should have the, cabozantinib and nivolumab as the comparator arm here. So that is what the system is using. So out of this setup, the system basically comes back with, let me open this, a couple of different layers for user to look at. It can either say there's some major issues in some of the questions, so it will color them red. It may say there may be a point to look at some of these questions, or the question is quite clear, so it is good to go. Without getting into these details, just to give you an example, the types of information that it will surface is things like this. So in the first question, for instance, we had how many patients were likely to be alive at 5 years. So this is the way that it was worded is counts rather than proportions, but the question doesn't give any indication of what the denominator is. So the system basically reviews the expert responses and then basically says, yes, this was a point of confusion. So before we roll this out, we can go back to the question. If we wanted to really have numbers in here, perhaps provide the denominator, provide some additional context so that the clarity is better when we roll out this question. And the user can, again, see all the individual answers to this question from different experts and so forth. And at the end, again, user can download this as a draft report. This can be downloaded as a JSON file that can be put in the platform to generate the visuals, etc., that the platform already does automatically. So I think, Lucy, I can pass this back over to you, but this is a nice addition of or leverage of AI to have an initial sense of how the survey may be interpreted and used by experts. The levels of scrutiny, criticism on these questions, etc., can be dialed up and down depending on the importance of the survey and what we are trying to achieve. But we thought we would show as AI as a complement to what we already do on the deterministic side. Lucy, back to you.
Perfect, thank you, Baris. So to find out more about the Elicitation platform, you can visit this link here or the website. And then the next steps would be to integrate the Gen AI into the platform. And this would be used to pilot surveys, assist in the survey development, and for qualitative results overviews. We're also developing an open source Seabiscuit R package with helper R functions for further analysis and visualizations. And visibility and feedback. So we would love to get more feedback from users to continue to improve the platform. Thank you for listening. Does anyone have any questions?
Thank you so much, Lucy and Baris. Yes, there are a couple of questions in the chat. The very first one of the questions is, are the experts the AI generates real people or sims?
They're all simulations, not real profiles. but it generates the profiles based on, again, the context that we provided. If it is a cancer-related questionnaire, it will probably create oncologist or whatever the profile that will look like for it, or the patient advocates in that space, or statisticians who will review such data for us, but not real personas.
Thank you so much, Paris. The next question is, does the AI follow existing guidelines when deciding whether questions are missing context or ambiguity, etc.?
That's a great question. I would say it can be done. The example demo that we showed didn't get into that level. However, as we are preparing those personas, we can gather that information online, the treatment guidelines, whatever is approved in that space so far, what are the off-label therapies. We can expand on that context that we want experts to use in answering questions. So they're all possible to include.
Thank you, Baris. We have also Dawn on the line. Please, Dawn, go ahead.
Yeah, I was interested in what you're doing with the fictional experts. One of the tasks that takes quite a long time within expert elicitation is identifying suitable experts to contact to recruit. So I was wondering whether a next step for AI assistants might be helping you to identify those relevant contacts and potential contact details for recruitment. Is that something you've thought about?
That's a great point. Yes, I think identifying experts by looking at, again, the literature or the decisions made in that space and the owners of those decisions, deliberations, etc., AI can be really helpful to pinpoint a short list of experts that we may want to reach out. That is very possible.
That was part of my question in the chat, Don, really. I think it's both come with benefits. Obviously, with it being completely fictional, you get away from kind of compliance problems that might come with using someone's name in a kind of simulated advisory board expert elicitation. But the other point of it is obviously this identification piece, which does take a lot of time, as you said. So both have benefits, but yeah, that's why I wanted to clarify.
Yeah, that's great. Thank you. Ben, I can see you've got your hand up next.
Yeah, thank you. Thanks for the beautiful presentation, Lucy and Baris. My question is similar to the one that just popped up in the chat by Clarice. And I wanted to know if you thought about disentangling what in the bio of the AI experts would sort of add the value for those roles. The question asked about factors such as age and gender, but I was also wondering, like, how detailed was sort of your description of the experts or the simulated experts' background and qualifications, and where do you think is the trade-off between getting too detailed versus getting a better response? Thank you.
Yeah, that's a great question. We haven't tested it out how the background and the persona we create impacts the types of responses we are getting from the experts. Very simplistically, when we were building this first time around, I intentionally put personas that have nothing to do with HTA or clinical perspective, like we had landscapers in there, plumbers, and so forth. Then we definitely picked up some very interesting results because they had no expertise in the topic of discussion. So this is to say, personas definitely fine-tune the responses that we are generating from these simulated experts. How detailed that they have to be, and whether age and gender or other elements are playing what type of role in the final response, we haven't really tested that out. But generally speaking, picking up experts or creating experts in the domain that we are interested in definitely leads to better responses and more relevant responses to the topic that we have in hand. Something that perhaps we should explore, by the way.
Great, thank you, Baris. We have also one question from Jeff Unif. Apologies if I'm mispronouncing. Have you considered validation of the AI virtual experts validation versus real-life completed advisory boards?
That's a great question. I think I will let Lucy speak to that because I haven't seen any real data set to go against with the simulated experts.
Yeah, no, that would be interesting to compare the AI to a real example. We haven't considered that so far, but we can definitely try and find some data that would have the ad board available to compare.
But one thing that I may perhaps comment is obviously simulated deliberations is not limited to expert elicitation. We have so many different meetings that happen, such advisory boards is one of them, HTA committee meetings, another one. In meetings where we bring together a bunch of experts to discuss a topic, all these can be tried to be simulated. In the past, I looked at a nice HTA review committee meeting, which again had obviously the information from the manufacturer submission redacted, obviously the confidential information, but also what the committee eventually ended up saying about the weaknesses and strengths of the submission. When I simulated that environment, there was a lot of overlap and alignment between the simulated environment and what actually happened in real life. So that is, I think, a signal to say when we set up these simulated environments the right way, there's a good overlap, and we can pick up good signals before these meetings happen.
Excellent. Thank you, Baris. There's a comment from Dawn. Dawn, would you like to comment on that?
Yeah, sure. The last NICE HTA lab AI workshop, they actually looked at use of AI to predict CDA decision making. So that's in Canada, which looked really interesting. And I think it's a bit easier than with NICE because there's an individual voting mechanism that's registered for CDA, whereas obviously for NICE committees, the actual deliberations all happen behind closed doors. So it's a bit more difficult to know how each of the individual committee members are contributing. But yeah, I definitely recommend people check that out if they're interested in use of AI profiles for generating decision making.
Thank you so much for that comment, Dawn. Any comment from you, Lucy and Baris, before we close this presentation?
No, just that was really helpful discussion, so we'll definitely take that away. Thank you.
Definitely. Thank you so much. This was super interesting, and actually this flows very well to the next presentation.